Hey everybody, Engine Doc back with you again. Got another little project going on here. We've got a Magneto to look at here. I don't know what I've got yet. A guy just dropped it off to me, said here it doesn't work. I'm having trouble with it. Sometimes it runs, sometimes it doesn't. Thinks it's a spark. He's had it rebuilt by one of the well-known Magneto rebuilders around our area. That's why it's so clean. It's clean inside and out. And he's already gotten it taken apart and has been looking at it to see what he can fix on it. And he's got the rest of the parts in here. There's little screws, and here's the coil, so forth. So let's see what we can do with this thing. Okay, so here it is. The guy's already taken it apart, and we'll see what we got. Here's a tag in here, looks like a Wico. Let's see, a Wico LD71B. Kind of interesting that let that focus on that, if it will. There it is. Looks like Wico has been inscribed with an engraver. So I don't know what we've got going here yet. So anyway, here's the coil. Looks like maybe a reproduced coil. And he said the problem with it was this wire broke off. So we'll have to look at that and see what's going on with that. Here's the cap that goes over the end here. And it has the points in here. He's got those loose. There's our little broken wire. We're going to fix that. And here's a modern capacitor. They've taken the condenser out and the old style and put in a 630 volt 224K it says, but we'll see what that is, measure it, go from there. There's kind of what we're looking at, dealing with here, so we'll get into it here. The rebuilder did a nice job of cleaning everything up. This thing's clean as can be. It's had a little bit of rust down in here, and what I've noticed on just initially looking at it here, looks like the impulse is working fine, but this thing turns kind of hard, and I see evidence down here of it rubbing. So we're going to take a close look at this bushing, and this bushing I can move it a little bit here. Probably can't see that on the camera, but I am able to move that, and so it may have bushing wear. It may be inconsistent because sometimes it rubs. We don't know yet. We're going to get into it, take a look, see what we've got to do to it here. Okay, I went over to the bench and loosened up this nut. This is an impulse unit, and this helps get the engine started. We'll explain about this later on in the video here, but I'll take this nut off, and we got to take this spring out, or release the spring, and get this this impulse unit off here. I want to check the bearing. That's what I'm after in here. So what you got to do is kind of finesse this, and it's hard to see, but there's a spring in there, and I'm actually releasing the tension on it right now. And let me pull that off, see what all we've got in here. Okay, there's your spring inside there. Get it up here so you can see it. Make sure I get it to focus. Anyway, there you go. Matter of fact, I'm going to change the focus on. Okay, anyway, there's your spring inside there. As long as I keep it inside a certain area here, this camera will focus on it. There you go. This is also a, oh, there's a, let me get it out here. It's a little washer. And matter of fact, I'm going to leave everything together. There's a couple little washers in there. And let's see. There's a washer. The larger washer here. Here's a stack of washers, stack of 3. Set them on there. This is the little arm that comes out and catches it and lets it impulse. This comes out here, catches this pin when it comes around, like so. And then when it rotates on around, it falls off of there, and that causes this to turn fast and gives you, from that spring, and gives you a good spark when starting. We'll pull that off. Get that off of there. And these things have to go back a certain way too. You can't get them 180 out, which it may have been 180 out if the guy had it apart. It doesn't look like he had this much of it apart because this is still dirty in here. And let's see, let's pull this armature out. There we go. Yeah, this is all dirty. He's not been here. So let's see how this works here. Oh, okay, that's pretty easy. What I want to make sure is I want to make sure I don't have any slop this way on this shaft, which would throw off your point gap and also allow the rotor to contact the stator here. So that's what I'm inspecting, and I want to make sure this bearing is good, so I want to get an eyeball on this bearing. So let me turn it around here and get you a better look at it. Try this here. Let me pull this out. As you can see, this is a bearing here. This is an outer bearing surface. It runs inside here. So that's a pretty good bearing surface there. These things go together, and that rotor slips over that, and there you go. So that's pretty decent. I'm going to call that decent. I'm going to call it dirty. It needs to be cleaned up, but I think we're good in there. This is another bearing out here on this end. Let me take these screws loose and we'll see what we've got in there. Are we going to get it all out of time? Yeah, we are. Is it worth a dang the way it is? No, it's not. It's not reliable. So what I'm going to do is go in here, figure out how everything's supposed to work, and put it together accordingly. So I know that this plate here can only go on one way because of this trip stop. And also on here there's some timing adjustments. You'll notice these all these screw holes are slotted, and also this trip is slotted as well. So I can set the point at which it trips by that screw right there too. So let's get these screw bobs out of here. Another thing I don't care for is there's a lock washer on there, and it's part of it is burying itself down in these grooves here. So technically there should be a flat washer on there. Anybody worth their salt in a rebuild shop ought to know that. So you know, I'm going to change that, put some flat washers on there so we're not burying those lock washers down in that groove there. So I don't care for that. If he even had this part of it apart, it almost doesn't look like he has because it's so dirty. Look how dirty this is in there. I'm going to clean all that junk out of there and see where we're at here. Almost looks like a thrust bearing surface there. So let me clean that up off camera, and we'll get back with you here shortly. Matter of fact, I want you to see this. Just now getting this apart. This is a washer, and that is some kind of a felt. I am not sure. What I'm looking at here, it might be a little bit of felt in there, maybe to hold lube. Yeah, I believe that is a piece of felt. It's soft, probably to hold lube in there, maybe keep dirt out of it. I'm going to do a little cleaning on this very, very gently. Get back with you here. Okay, as I suspected, this is a lubricating felt. Let me get it pulled out here. That is one big piece of felt. And let's see what's in behind it. Get a magnet here. There's a plate back here. It's got a couple springs on it. Check that out. Goes down this housing. Holds pressure out on that plate. Oh, I see. There's an oil hole down in there. And that's what holds... Apparently that's what holds the lubricating oil for the bearing. So that you can't over oil this thing, because if you over oil it, of course you get oil out on your points, and that causes problems. And so yeah, wow, haven't figured these two screws out yet, but I thought maybe they aligned the bushing in there, but they don't. So that's pretty dirty in there. I'm going to clean that up. I'm going to clean this felt up just a little. I'm not going to clean it up much. I'm just going to knock the big chunks off of it and let it absorb the oil like it should. And I think I'll put this much of it back together, because once I get this clean and oiled, I think the bushing's okay. The armature is pretty dirty here. The rotor pretty dirty. But let me get this much of it cleaned up and I'll get back to you. Okay guys, this is genius. Let me first show you what we've got here. Show you the basics. This is made out of steel. Steel shaft sticking out here, hollow. The bearing itself, the bronze bearing itself, is in here. I'm just going to try to show you as much as I can here with my limited video stuff. But anyway, this is a bronze bushing. Looks like it appears to be pushed in there. So when you put this together, that big bronze bushing in there has a lot of surface area, this much surface area that runs on here, and that runs together. And I don't see any reason that is too loose. I've got a little play in there, but my gosh, you got to have play for a thermal expansion and that kind of thing. So I don't see the amount of play in here being any kind of an issue, because the amount of wear I see on things here just doesn't appear to be wore out or even have a whole lot of hours on it. So I'm going to call that bushing okay. Now, here is the genius part. This is absolutely genius. So this felt goes down in here, and its sole purpose is to hold oil. This has, in the most crude way, an oil pump. These screws here, depending on how the thing's mounted and the access to them, this is where you add oil to this. Now, farmers back then and people who had these engines were notorious for two things. One is over oiling something, or two, not oiling it enough. these guys apparently were trying to address this problem, because once this has oil in it, it's pretty well maintenance free at that point. It'll go a long time before you have to worry about it. So anyway, here's what's going on. The felt goes in here. You add oil in these screw holes, and against the felt, I'll show you when I get it back together, but here's a disc, and you can see the wear marks in it where it has been running against that felt. So anyway, that goes like that. Now if you look close, I'll try to get you up here close. Here is the heart of the system right here. If you take a look, I'm trying to get a light set up so I can show you all at the same time. There we go. Let me get a screwdriver here. Alright, this is a little wiper, a little phenolic wiper. It's made out of some kind of phenolic material. And it is fixed in there in such a way that it's spring loaded. And if you look close, there's a little trough right here that runs down this way, back toward the back. It drips in a hole and oils this bearing. And what happens is, this disc runs against the felt. As this whole thing's rotating, it picks up a little bit of oil on this disc, brings it up, and this little squeegee squeegees it off, and it runs down a trough and lubes this bushing. Absolutely genius. Whoever thought of this back then, I don't know what he was smoking, but I want some. But anyway, this is absolutely genius. So it picks up oil, drizzles it, gets squeegeed off here, drizzles it down this little trough, lubes the bearing, and the cycle continues. And if you look in here, you'll see that this is actually drilled. See if I can get a light back here. You can see that that passage is drilled, and this groove on the bottom of this stud sticking out here, this hollow stud part of the bearing, it's got a groove in it. Well, that gives the oil a place to run back and drip back in, and it drips back into the felt area right here. So it's continually circulating oil through here. Now, I think that's just pretty cool. I can see some problems with it. You know, you don't see that anymore. There's a reason. But yeah, that's another way of solving an issue, a lubrication issue in these magnetos. These things were neglected. You know, all the old farmer wanted to do is go out and fill his, run his water pump and fill his cow trough up. You know, he didn't care how much oil was in here, when it got lubed, if it got lubed. You know, most of them didn't think about things like that. They had too many other chores to do. But some engineer somewhere probably has his own island from coming up with this deal. It's absolutely genius. It's absolutely genius, but, you know, is it over-engineered? Yeah, I think so. Well, I've wiped this off. I'm not gonna put any solvent on or anything like that, because the solvent will degrade the oil that goes in here. It's still squishy, still in pretty good shape. I can tell that it was once that sort of red colored felt, and it's got a little dirt on it, but I'm going to let it go. I'm going to stick it back in there, and it just lays in there just like that. And this doggone felt, this disc runs on it, carries oil up there. And this is the reason why the rotor turned. It felt like the rotor was rubbing something in there. That's why I went in to look at the bearings. Thought maybe that had a bearing issue, but no, it's rubbing on this felt and moving oil. So that's something else. Something else. Oh, I forgot the spring-loaded. Let me back you out here. Get it pulled back out. There's a spring-loaded plate. This one that goes back there and keeps pressure, keeps that felt pushed out against the disc to keep moving oil. There we go. See it moving there? Yeah. So anyway, and then this rides on the rotor, and it runs in this bushing, and that feels great. No problem there. So I don't think our bearings are the issue. Well, I'm getting ready to get this put back together here. I've got my oil can out. I'm kind of soaking this felt here with oil, and get this end of it put back together. I think we're pretty well ready to close this end, and that's why the gasket's on here too, because it's got to hold oil, so that's pretty interesting. So I'll get this together, and we'll get the impulsor on it and preloaded and all that. So I want to set the disc that carries the oil in there, and then this washer goes on top there. It goes like that, and then this turns over. This is merely an oil seal. It's got grooves on in there, and after I got it cleaned up, I noticed that it's just an oil seal. So that sets on there like so, and that spring-loaded felt's holding me out there like it should. Line up my shims in there. Forgot the gasket. Let's put it on there. The gasket goes like this. Whoops. That back up there. Gasket goes there. The gasket's torn a little bit, but it's up the top where it doesn't make any difference. Need to get a little better way of holding it here. There we go. And this sits on there. Line up the shims like so. And I'm going to clean these threads of these screws and go get some flat washers for this. I'm just going to make sure my threads are clean. Using a little wire brush here. A little bit of debris in those threads, so don't want to get anything in there that would strip out that aluminum. There we go. I keep knocking this thing over. Okay, found a few little washers here. They're going to work pretty well. That's the way it should go. Oops, sorry. Yeah, I had to change a battery there on the camera. Put these, I think I'll get all these screws started in the holes, and then I'll run the shaft through it and align those spacers in there. There we go. Now I'll tighten this down in the neutral position, in the halfway in the groove there, which is right there. continue on with assembly here. Okay, now I can pull that out and it not move. I will lube up everything real well and stick it back. And that turns a lot easier now against that felt than it did, so that's good. Okay. And I'm going to clean these parts as I put them back together here. And so everything's nice and sanitary. Here's the pawl that catches on this stud here. So let me turn around, you can see it better. This stud here, and this is what causes the impulse. And what happens is what it does is this sticks out here so it can catch. And then as soon as the engine starts running, this is heavier on this end, so it'll sling that back and pull this in like that. And then when the engine slows down, this will come back out and catch that and impulse the mag at slow speed, cranking speed, just so you can get it started. And as soon as the engine's running, this centrifugal force brings that weight in and pulls the pawl in, and the pawl no longer catches. That's why you hear the impulse at slow cranking speed, and as soon as the engine starts up, you hear it stop clicking. So that's how that works. So that goes on first. Then the washer stack, we clean them up as I put them back on. So everything's nice and clean. The big washer. Another small washer. And now the spring and that assembly. Matter of fact, I think I can pull that out of there. Like so. So it turns over, goes on like so. Now this is where you can get things backwards, and if I get it backwards, I'll just have to take it apart and correct it. I'm putting this little tick mark here to the top of the Magneto. And when I put this together, that spring fits in there. Push that spring down in there all the way so it holds all that stuff like that. Turn that over, stick that in like so. Now I'm ready to start preloading the spring. And to preload the spring, I want to turn this counterclockwise. I'm going to hold on to the rotor back here so I can grab this and turn him. And I got to clear the screws. And I also have to keep this rotary pawl inside. It's wanting to pop out too. There we go. It's kind of a balancing act getting this all to wind up here. Here we go. Like so. Now when I took this apart, it felt like it was preloaded 2 revolutions, but I got 1 on it now, and I'm almost thinking that's enough. I don't want it flipping so hard it breaks the spring in there. And right now, when the pawl comes around, it catches it, and that's fine. This little pawl here. And then when centrifugal force takes over, it pulls it away and it doesn't catch here anymore. So I think I'm going to leave it right there. I can always change that later. That's not a big deal. I'm going to put the nut back on it and leave it there for now, and make sure that I've got it together correctly. I may have it 180 degrees out, and I may have to pull it back apart and change it. So that's something that can be changed later on. Pretty easy. So tighten that up a little bit. Later on I'll put a drop of Loctite on those threads. And let's see if the impulse works here now. Oh yeah. There we go. Let you watch that rotor. See how it flips it all of a sudden? Okay. So, and then when it's running fast, it doesn't catch it all. So, there we go. That part of it's done. Okay, so on to the next problem. The next problem is this broken wire on the coil. I don't think that's going to be much of an issue. I'm just going to solder another wire on there and we'll make that work. So that's no big deal. I think this coil's been rewound. It looks good. Then we got to figure out the points here. One issue, let me get it up here where you can see it, is that the actual points don't contact each other squarely, and that's a problem. And as far as I'm concerned, I'm going to try to address that problem. But what we've got going on here is this arm is insulated from this part. So we've got insulating washers here on this screw, and I think we're also insulated here. And of course there's a piece of insulation going around here so that this screw or this spring can't contact and short out there, so that whenever this makes contact it grounds the coil. So I have to pay attention to what's grounded and what's not here on this thing. So before I go messing around too much with this, take anything apart, I'm going to make sure it's not already shorted out or something like that. And let me turn my buzzer on here. There we go. Let me do some testing here with the points open. Yeah, it's shorted. I think possibly a lot of our problem may be right here. Everything's shorted together. Now let me stick something in between something insulated in between the points. And matter of fact, those points can't open without them shorting out against here. Here's an issue. Get you up here closer, you can see it. Whenever this opens, this arm comes back down here and touches here anyway, so that's going to have to be addressed, so that when they're open, these two contacts here are not, there's no continuity here, and then when the points close, it is able to charge up the coil, and then as soon as the points open again, it discharges the coil and fires the plug. Well, I've got the points out of it here. I've bent this just a little bit so to square up the points. I mounted it back in the housing, and so I wouldn't bend anything else, and bent that a little bit. And then there's a little bit of pitting on these. See if I can get you to see that there. Just a little tiny pit there. I want to take that out with some crocus cloth. Here's the stationary. It doesn't look too bad, but I'm going to polish those surfaces. So critical that those surfaces are polished and not filed. So you just work it with some crocus till you get a polished finish. That's all you can do. And I'll just basically take crocus cloth, which has jeweler's rouge on it. It's a real fine polishing cloth. I just work those points down to where they're polished. I won't get rid of the pitting, but I'm also changing the contact area so they won't be touching where the pit was. So that should fix things as far as the proper contact goes. Alright, I got to looking at the coil, and matter of fact, I just cleaned these wires. I'm going to solder this wire back together just for testing. I think that's all we need to do, but I could put another new wire on there, but this one's already got the lug on it and everything, so I'm just going to solder that back on. But anyway, I got to ohming it out, and there wasn't any continuity between the primary and the secondary. The secondary's got to be grounded here, so there wasn't any continuity there. And got to looking on this pin. I don't know if you can see that or not. Let me get it close enough. I've actually taken my knife and scraped off a coating that's on that little pin there. I think that's part of a stick pin or something that they used for a contact, but you know, it works. At least it should work. And I don't see, this engine's been running since this mag was rebuilt, but there was a coating on there that I scraped off, and then I could get continuity here. And it's like 1.8 megs, which is really, I think it's too high, but I'm going to try it. But this had a stupid coating on there, and I don't know, I didn't see any burn marks where it had been firing through it, so I'm not sure how that was working. But I wasn't getting any continuity until I scraped that stuff off there. I got to looking at it and said, that looks like some kind of a coating on there or something. And so I took my knife, sure enough, scraped that off, and now I've got, you know, continuity between these two. Of course, I got a low resistance between these two, so which is correct, but we'll see what this thing does. But that was kind of odd. You know, the engine's been running before, and I would think I would see a burn spot through there, but maybe not. But anyway, this spring that's on the back of here contacts that and transfers the spark out here to the spark plug wire. So anyway, all right, I'm going to wrap it up for now and be back at it later here. Okay, what I've done now is I've gotten the points mounted in there, the little horseshoe bracket. I've refitted everything. It looks like it's going to fit fine. I had to remove this nut and turn this mechanism 90 degrees because my flat surface here was in the wrong place that opens and closes the points. Got that done. I have soldered a wire on here to where this wire was broken off. I'm going to get a little piece of heat shrink on there and get that taken care of. I'm going to run the wire back around a little different routing, take some stress off of it, and get ready to mount the coil up in here and see if it works. I'm not going to use a very big piece of heat shrink here, just a little short piece. And just enough to cover my solder joint. Slip that over there about like that. I think this thing still works. Good God, I don't need that much heat, but sounds like way more heat than I need, but it worked fine. Now I'm going to rotate this around. Let's make a circle out of it here. And there's a relief right here. I'm going to bring that down, that wire down through. And that'll hopefully take the stress off of it and bring it around here and bring it out. Hopefully without touching anything in there. So now this goes like that. So this, I want this on the bottom. So I'm going to stick that in there like so. The coil just slips on there, and then there's a little ridge inside here, right here, that keeps the coil from slipping down into the rotor. So that's a pretty cool piece of engineering. So let me slip that in. Turn this, clock this thing so it can't catch that. Get my bolts lined up, studs. Slip it together like that. And now I should have enough clearance. Looks like I've got clearance on the rotor, and this really doesn't clear until I tighten these bolts up, but I'll make sure that rotor can't contact that wire in there, and we are well clear of it. So, well, no, I'm not either. I don't care for that. Let me pull it out of there and try it again here. It's just a matter of mocking the thing up, testing it, seeing what it needs, putting it back together, mocking it up again. I'm going to try to work that wire around a little bit there. Problem is, this little wire kept trying to bop out of this groove here. So I need to hold that in place. I think I'm just going to wrap a tie wrap around there. It won't hurt a thing. Something like that. Now that wire can't get out of there. Let me pull that good and tight. There we go. Snip that off. Let me see if that'll fit in there better now. Goes like that. This goes like this. Like so. This button has to be clocked so this contact here, when this cover goes on, that little spring will make contact on the button. There, I like that better. Okay, let's go with it. Back together for the 200th time here. Several times off camera. Make sure the magnet hasn't picked up any metal particles. This rotor is magnetized. There it is. Now, I finally like that. Make sure that rotor cannot touch that wire in there. Looks great. Okay. All right. I think I'm good to go there. So let me put these nuts on to hold that lamination in. And I'll be right back. There's two different sizes of studs going through here, and I don't know why they did that, but I'm going with it. Not going to change that since this works just fine. Run these nuts up, tighten them up. And make sure after I draw this iron laminated core up that my rotor turns free. These two little ones up here. Get the right wrench. I may not have the right one out here. There it is, 9/32. The larger nuts down here are 5/16. I can see that draw those laminations together. Bunch of layers of iron that makes up the core for the coil. Okay, and yes, we turn good. Nice and free. Should be making power on those two wires right now. So there we go. I'm telling you, the clearance in there is just tight as it can be. I don't know if you can see that or not. I'm looking in the monitor here while I'm trying to show you this tightness in there, but it's tight. But as long as it doesn't touch and there's no way that the wire can jostle into the rotor, we're good. So we're going to go with it. Now that I'm back together this far along, I'll explain what happens here. This iron core of these laminations here, they take the magnetism from this rotor. There's a north pole and a south pole. And basically, let's just say this is the north pole and this is the south pole. So as the north pole rotates past the laminations that go down through the coil, between the north pole and the south pole, this area here and this area here, as that magnet spins past that coil, it creates a charge in the coil. It actually induces some voltage into this coil of wire. Then, as it rolls around, there's a flat right here. As it rolls around, the flat, during the charging of the coil, the points are closed. As it rolls around, the points open And while this coil is charged, when the points open, that charge that's in the coil wire collapses, shuts off, collapses. And as it collapses past the secondary windings, that's when the high voltage is generated in the secondary windings, and that's what creates a spark. So basically, as this spins, the points are closed, allowing this magnetism to induce into the coil. Swings by, the points open, the coil discharges, the magnetic field collapses, and when that magnetic field collapses past the secondary windings, that's when the spark occurs. So it's very simple, but everything has to be right. These clearances have to be correct, the point gap has to be correct. Here is the condenser, the modern condenser. The other one was big enough, I don't think there was room to mount it inside here, really. But anyway, these modern condensers, capacitors, are small enough it doesn't make any difference. They actually work better than the old big metal cans. So that's basically how the mag works. So these wires have to be kind of down this way. I have to slip this over. Slip it over the studs, make sure my wires are accessible here. Get the cap put on, make sure I can get the points over the cam, and they are. And there we are. This one happens to be almost lined up with a screw hole, and then this one goes on right here, and I've got room to play with on this one, so I'm gonna maybe just cut 1/4 of an inch of it off and solder this lug on there and put the capacitor in there, and it's time to test it. So I'm going to go ahead and bolt this back together. Again, the smaller nuts go on top, looks like, and the larger one goes on the bottom. This is a little cover clip here to hold the points cover on. Let me get him tightened on there. Try to tighten them all evenly. 9/30 seconds, there it is. It's just a matter of, there's some documentation on this Magneto on the web. I saw some stuff on there, but just a matter of taking the thing apart, figuring out what the engineers were thinking, and just trying to put it back like they built it, and go from there. So now let me get the wires hooked up. I've got to get a terminal end soldered on here. We'll get the condenser mounted back in there and get this terminal back and go from there. And in handling the capacitor here, this broke off, so got to fix that. Okay, I stripped off a little piece. This is the wire that come off the coil that broke off that I replaced. There's magnet wire in there. That's what the coil's wound with. So I'm going to attempt to solder a little piece of that on there. But first thing I got to do is see if I can get this little nub there tinned. I got my soldering iron hot here. Let me see if I can even get that to tin and get my iron clean. You got to be careful when you do that and not get the end of that capacitor too hot. Yep, I believe it did tin. It took just a little bit of solder, and I believe it got tinned there. So let me tin this piece. I'm going to leave that piece of, well, let's see. How am I going to do that? Go ahead and peel this heat shrink off of here. Got my strippers here. Get that peeled off. And let me go ahead and tin this piece now. This little piece of wire here. There we go. I'm wiping the tip clean there. Now let me see if I can get a little glob of solder to hang on there about like that. I know you guys can't see this, but some microscopic work going on here now. Let me get some solder on the iron and touch that just like so. Maybe. We're going to try to make her work. So now then, I am going to put another little one of these lugs on there. Let me see if I can find one. Cut that off. Now to get anything to stick to that, you got to take that red coating off. And it's just painted on there, so you take a blade and scrape it off. Trying to get all that red coating scraped off down to bare copper. Getting it just takes a little time. Anytime you deal with magnet wire, this is what you deal with. That's how they can wrap it in a coil and have it not short out. Each turn short out against one another because it's got this insulation on it, which is nothing more than, I think, a lacquer type finish. Just takes a little finessing to get that red stuff off of there. There we go. Pretty well have it now. And that gives me a little nubby stubby there to work with. I saved my ice cream lids. For this. Sort through here and see if I can find my smallest lug connector. These little square ones are the closest I have. And that big old blue insulator on there is right in the way, so I'll grab that with a pair of pliers, pull that off of there. You can get rid of those insulators that way. Leaves you with a much smaller little connector. So I'll get my crimpers out here and get that terminal loaded in there, like so. Get my capacitor here and stick the lead in, get it aligned about right. Crimp her down. That should do it. Now if I try to solder that, what's going to happen is it's going to get hot and my other little solder joint's going to come apart. So that's going to work. A crimp joint is a lot of times better than a solder joint anyway. So let me strip the end of this wire. I'm going to cut off about 1/4 inch of it. Strip that. Try not to pull on it too hard. I'm going to crimp another end on it. Get my end loaded into the crimper. Shove it over. Crimp it. Always do the tug test, and yep, that works fine. So there we go on there. Now comes the finessey part of getting this capacitor stuck in there and a screw put in it. And I'll take the cap and stick it in there. By the way, these new capacitors are not polarized, so you don't have to worry about getting a negative and positive in there. I'm close. I've got my screw set up in the screw starter. Let me see if I can get that with my old fumble fingers here. Get that started. This is where the screw flies across the room and you end up going and finding another one. Get it lined up there. Oh, there it goes. My screw starter's just a little big for this tiny screw. Let me try it again here. There we go. We're getting there now, I think. This is where you gotta hold your mouth just right to get that screw started. Like so. Now I gotta get this one bent. Since this is ground, we don't care if that touches the case. Bend that down like that. Get that screw out of there. And let's see if we can get this one started. Believe it is, yep. Okay. See if I can rotate everything without anything touching in there. And I can. So let's test it. Okay, since I've got the two wires there, the positive and negative coil wire, when the points are closed, we should see real close to whatever the short circuit is. Hang on just a second here. Let's see what we got here. There, the points are open. I'm seeing a 1.8. There, the points are closed. Almost. There we go. That's a dead short. Points open, I should see the continuity of the coil, which is 1.8. Yep. So that's working. Otherwise, to test the points and everything, you'd have to take one of the coil wires off. Okay, let me strip up a piece of wire here and get a bare end on it here. Let me stick it down in this spark plug wire deal here. Now I'm just going to hold it This is where you happily get shocked, because if you get shocked, you know you did well. And that should jump that little gap right there with the impulse. Let's look. Get it wound up on the impulse here. Oh yeah, we got a spark. Try it again. Oh yeah, got a good fat spark. Very good. Actually, I should be able now to, yeah, just do that. Oops. If I get it started before it, there it goes. I don't know if you can see that or not, but that'll give me a spark too. Yeah, good hot spark. Very good. I'll put the tag on it now. Tag goes up here. A couple of screws left and we're done. Get my screw starter again. Handy tool. Oops. So I hope I didn't bore you guys too much with this. That's not going to work on that. I'm going to try to start that by hand. With this kind of repair, if you like what you saw, give me a thumbs up. If you don't like it, keep your mouth shut. Just kidding. But appreciate you watching. Hope you found out a little bit of something about how these old mags work. What the engineers are trying to think, you know, how they were, the problem they were trying to solve back then. It's amazing the engineering that went into these things, as old as they are. We sometimes have to take them apart and figure them out and make some repairs and keep them going. So appreciate you watching. Thank you.